All right, we're going over Chapter 5, Review A for the test for Chapter 5. So, the first set of problems ask us to solve. Number 1. The first thing we should do is go through and identify ones that are going to give us problems. Do I have to check for extraneous? Do I need to look for domain? Okay, so extraneous has variables on both sides. Domain is a less than or an inequality with an even root. So I need to look at domain on number 5 because this is the square root of a less than. So that's going to need domain. And then the only problem with variables on both sides is number 1, so I'm going to have to check for extraneous. Those are points that you're going to lose if you forget to do those steps. So number 1, x minus 4 equals the square root of 2x. Well, if I want to get rid of the square root on this side, the square root's already by itself, I'm going to square both sides. And remember that to square x minus 4, I have to do x minus 4 times x minus 4, which is x squared minus 4x plus 16, which is x squared minus 8x plus 16. That equals 2x. Now when I have an x squared and an x, we're going to get it equal to 0. So x squared minus 10x plus 16 equals 0. And now we can factor what two numbers multiply to 16 and add to negative 10. Negative 8 and negative 2. So this factors to x minus 8 and x minus 2. So x is equal to positive 8 and positive 2. Now we go back and plug it into the original equation to see if it works. So we have to check for extraneous. We have to show our work. 8 minus 4 is equal to the square root of 2 times 8. 8 minus 4 is 4. 4 equals the square root of 16. 4 equals 4. Check. So 8 works. Now let's check the 2. 2 minus 4 equals the square root of 2 times 2. I get negative 2 equals the square root of 4. And negative 2 does not equal positive 2. So 2 is extraneous. So my only answer is that x equals 8. All right, number 2. 6n minus 5 to the 1/3 power plus 3 equals negative 2. So I need to get the parentheses and the exponent by itself. So I'm going to subtract 3. Get 6n minus 5 to the 1/3 equals negative 5. Now remember the fractional exponents are the roots. So in order to get rid of the 1/3 power, I need to raise this to the reciprocal third power. So I'm going to cube both sides. 6n minus 5 equals negative 125. And then add 5. 6n is equal to negative 120. Divide by the 6. And n equals negative 20. Number 3. 2 times x minus 3 to the 4th minus 10 equals 152. So we're going to solve this first by getting that term by itself. So plus the 10. 2 times x minus 3 to the 4th equals 162. Divide by the 2 in front. X minus 3 to the 4th equals 81. And to get rid of the 4th power, I'm going to take the 4th root of both sides. So I get x minus 3 equals plus or minus 3. I took the even root. I always need a plus or minus with my even roots. And then we're going to add 3 to both sides. Remember that 3 goes in front of the plus or minus, so it becomes 3 plus or minus 3. 3 plus 3 is 6. 3 minus 3 is 0. So x is 6 and 0. Now the domain for 4th power and in the 1/3 power is all real numbers, so I don't have to check for extraneous. But you should plug it in to see if you got the right answer. All right, let's look at number 4. 2/3 and plus 1 cubed plus 18 equals 0. So again, I need to get my parentheses and my exponent by itself. So we're going to subtract 18. 2/3 times n minus 1 cubed equals negative 18. To get rid of a fractional coefficient, we multiply by the reciprocal. 3 over 2. N minus 1 cubed. We're going to cross cancel here. 2 goes into 18 9 times. 9 times 3 is 27. So negative 27. Then I'm going to take the cube root of both sides to undo the cube. Remember, the cube root of a negative is negative, so I get n minus 1 equals negative 3. No plus or minus on odd roots, only the evens. Add 1, n is equal to negative 2. Now 5 is the even radical x plus 4 plus 1 and less than or equal to 7. So first I need to look for my domain, that x plus 4 must be greater than or equal to 0. Whatever is under the radical always has to be greater than or equal to 0. So x is greater than or equal to negative 4. So my answer can't be anything less than negative 4. Then we'll solve the equation. Minus 1, square root of x plus 4 less than or equal to 6. Square both sides, and x plus 4 less than or equal to 36. Minus 4, and x is less than or equal to 32. Now that's where my domain comes in. Negative 4 is the lowest it could be, so I'm going to put less than or equal to negative 4 on the other side, or negative 4 less than or equal to x. And that's my final answer. The absolute, or the inequality, the between statement. That's because this is even, right? And then it's less than. Now be careful with the greater thans. If the sign flips at some point, then it's going to need the domain restriction. So check it for any even radical. And lastly, number 6 in that set is the cube root of x minus 6 minus 2 less than or equal to 2. Now an odd radical is allowed to be negative, so I don't have to worry about the domain restriction. It can be any negative or positive number. So I'm going to add 2 to both sides. Cube root of x minus 6 less than or equal to 4. Cube both sides. And x minus 6 is less than or equal to 64. Make sure you have those numbers memorized in your nth root table. Practice those flashcards if you haven't. Add 6 to both sides, and x is less than or equal to 70. All right, the next set is the rules of exponents, making sure we have no negatives in the final answer. So remember our rule of exponents, if we're multiplying, we add our exponents, but the bases have to be the same. We have the same bases here for number 7, 4 to the 7/3 plus 4 to the 5/3. So I can add my exponents, my bases stay the same. So it's 4 to the 12/3 power, which is 4 to the 4th. And that's pretty small, so we can evaluate that to be 256. Number 8. Number 8's one where I like to simplify what's inside before I deal with the exponents. And I like to move my negative exponents up or down so that they become positive. It makes the subtracting a little bit easier. So I get 12 divided by 6 is 2. So I start with that. I'm going to move this a to the negative 6 to the denominator and make it positive. I'm going to move a to the negative 2 to the top and make it positive. Then my b to the 5th and b to the 4th stay where they are. And I'm going to take this c to the negative 2 and make it positive and put it in the denominator. Now I'm going to simplify this. My a's, 2 minus 6 is 4. So 2 and a to the 4th in the denominator because there's more a's in the denominator. 2 minus 6 is negative 4. Negative exponent in the denominator. B to the 5th divided by b to the 4th, b to the 1 power, and c squared stays in the bottom. Now I'm going to deal with the negative 3 exponent. The first thing I'm going to do is deal with that negative, and it's going to flip my fraction, a to the 4th, c squared over 2b to the positive 3. And then I'm going to apply the 3rd power to everything. A to the 4th cubed, multiply my exponents, a to the 12th. C to the 2 cubed, multiply 6. 2 to cubed is 8, and b cubed. Don't forget that this b has a 1 there, so it needs to get multiplied by that exponent as well. Now number 9, I do a little differently. Notice no parentheses, so I don't have to apply any exponents. Number 9, when I have a fraction times a fraction, I like to multiply across the top, multiply across the bottom, and then deal with my simplifying. So first I have 3 times 20. I'm not going to multiply that out because it's going to make simplifying easier. X to the 5th and x to the 4th is x to the negative 1. And y to the 2nd and y to the 9th is going to be y to the 11th. And in the bottom, I have 4 times 12. Again, I'm just going to write it as 4 times 12. My x to the negative 3, x to the negative 2, add those exponents, x to the negative 5, and then y to the negative 3. So my negative exponents in the bottom are going to move to the top, and my negative exponent in the top is going to move down. So I end up with 3 times 20, x to the positive 5, y to the 11, y cubed, over 4 times 12, x to the 1. Now I'm dealing with my numbers. 4 goes into 25 times, and 3 goes into 12 4 times. That's why I didn't multiply it out, because it's easier to simplify that way. I get 5, x to the 5th divided by x to the 1 is x to the 4th. 4 in my denominator, and y to the 11th times y to the 3rd is y to the 14th. Highly suggest going back and looking at your previous quizzes on these problems and repracticing them. All right, now we're going to find the inverse. Remember, our steps for finding the inverse when it's in an equation is change f of x to y, swap my x and y, and then solve for y. So for number 10, I'm going to make this y equals 2/3 x minus 10. I'm going to swap my x and y. X equals 2/3 y minus 10. Now I need to get the y by itself. So we're going to add 10. So x plus 10 is 2/3 y. Multiply by the reciprocal. 3 over 2 times x plus 10. So 3/2 x. 30 divided by 2 is 15. So 3/2 x plus 15 equals y. So this is what I did over here with the fraction. 3 over 2 times 10 over 1. 30 over 2 is 15. Or you go 2 goes into 10 5 times, and 3 times 5 is 15. So the inverse, F inverse of x, is 3 over 2x plus 15. Same 3 steps for number 11. Change it to y. Swap x and y. And get y by itself. So to do that, I'm going to multiply by 8 to get rid of the denominator. 8x equals y plus 2. Add 2. 8x plus 2 equals y. So my inverse f to the negative 1 of x is 8x plus 2. And number 12, the super easy one. All we got to do is swap our x and y here. I get 6, 5. 7, negative 3. The signs all stay the same. And 0, 4. Simplify using absolute values when appropriate. So when is that appropriate? Remember, we said when we have an even index of an even power, and that ends up as an odd exponent, we have to put absolute value around that answer. So for number 13, remember the shortcut is I can divide my exponents. 40 divided by 8 is 5. So I get negative 2 to the 5th power. 8 is even, 40 is even, the resulting exponent is odd, so I need absolute value bars. Negative 2 to the 5th power is negative 32, and the absolute value of that is positive 32. Odd root, negative, that's okay. So I can take the cube root of negative 8 is negative 2. The cube root of a cubed is just a. And the cube root of b to the 14th, well, I'm going to do 3 goes into 14 4 times with a remainder of 2. So that means b to the 4th goes outside my radical, and b squared stays inside. Now I don't need even. I have odd here, so I don't have to worry about absolute value. Number 15. Number 15 is even. I might have to look at absolute value on the odd, or on the x, because it's even. So the 4th root of 81 is 3. 4 goes into 38 9 times with a remainder of 2. 4 goes into 17 4 times, remainder 1. So for the x, it's going to be x to the 9th outside. Let me move this down here. X to the 9th outside, y to the 4th outside, and the 4th root of x, the remainder is 2, so x squared inside, and y, remainder 1 inside. You can write the 1 or not. Now the x went even, odd, so I'm going to put absolute value around the x to the 9th. Number 16, can an even root be negative? No, this is undefined. Okay, look for that problem. Identify it right away. Number 17, remember that this is the square root. So the evens, I have to look out for absolute value here. The square root of x to the 4th. 4 divided by 2 is 2, so x squared. 10 divided by 2 is 5, y to the 5th. That was even, odd, so I'm going to put absolute value around my y to the 5th. All right, now we're going to simplify some radicals. Remember, if it's fourth power, I'm looking for groups of 4. Remember, the parentheses together mean multiply, which is different from this one, which is add and subtract. So I can multiply any radicals together as long as they have the same index. So we multiply the numbers in front. Negative 2 times 1 is negative 2. And now I'm going to just keep these under the radical as 88 and 44. So I have 8 times 11 and 4 times 11. 8 is 2 times 2 times 2, and 4 is 2 times 2. I need a group of 4. So I have 1, 2, 3, 4 2's. So they come out as a 2, 4th root of what's left over. 11 times 2 times 11, that's negative 4. Multiply the numbers outside. 4th root of 121 times 2 is 242. Number 19 is multiplying the distributive property. So we're going to multiply square root of 21 times 5. 5 square root 21. Square root of 21 times 3. Minus the square root of 21 times 3. We need to check to see if that's simplifiable. 7 times 3 is 21 times 3, so we have a pair. So that's 3 square root 7. And 5 square root 21 minus 3 square root 7. Those don't have the same number under the square root, so I can't add them together. That's what I need to make happen for number 20. I have to have the same number under all the radicals in order to add them together. So we have 8 times 4, which is 2 times 2 times 2. That's 8. 2 times 2 is 4. So I have two pairs of 2's. That gives me 4 square root 2. And then 18 is 9 times 2. 9 is 3 times 3. So I have 9 on the outside. 3 pair of 3's come outside. Square root of 2 is left inside. So that's plus 27 square root 2. And 50 is 5 times 10. 10 is 5 times 2, pair of 5's. So that's going to be a minus 2 times 5 comes outside. 10 square root 2. 2 times 5 outside. So now I have 4 plus 27 minus 10. So that's 31 minus 10 is 21. So 21 square root 2. And number 21 is the division. So it's a 6th power. I have to get the radical in the denominator to go away. The only way I'm going to do that is to have 6 of everything. So I'm going to break down 27 as 3 times 3 times 3, and then 1a. So when I multiply by something, I need to multiply by whatever is going to give me 6 3's and 6 a's. So since I already have 3, I need 3 more 3's. If it was 5th root, I would only need 2 more 3's. And I need 1, 2, 3, 4, 5 a's. So on the top, I multiply by the 3 times 3 times 3 is 27, and the 5 a's is a to the 5th. So I get 27 times 4 is 108. 6th root of 108, a to the 5th. And in the bottom, you end up with the 6th root of 3 to the 6th, a to the 6th, which is just 3a. So the 6th root of 108, a to the 5th, over 3a. Okay, so given these three functions, f, g, and h, This should be an n. So that should be 4n. Find f of g of -1. Now, just a side note, your notation could also be f with a little circle, g of -1. That means the same thing. It means take -1, plug it into g, take that answer, and plug it into f. So we're going to start by finding g of -1. G is -3n plus 2. I'm going to plug in -1. Positive 3 plus 2 is 5. Now I'm going to plug 5 into f. That's 2 times 2n squared minus 3n. And I'm going to put 5 in for the x, or the n in both of those equations. Remember to do your exponent before you multiply. 25 times 2 is 50 minus 15 is 35. So f of g of -1 equals 35. Now f of g of n means I'm going to take the whole function f and plug it into g. So when I do that, I like to rewrite the function g, -3 parentheses plus 2. And then what's going inside the parentheses is f of n, 2n squared minus 3n. So I'm putting the whole function into the parentheses. Then I distribute -6n squared plus 3n plus the 2. So g of f of n is -6n squared plus 3n plus 2. And then we have f of h of n. So that means I'm going to take f of n, which is 2n squared minus 3n. Right? So I like to take that first function, put big open parentheses, empty parentheses, and then I'm going to put 4n in for them. And 4n squared is 16n squared. Remember, that's 4n times 4n, so n times n is still n squared, minus 12n, 32n squared minus 12n. So f of h of n is equal to 32n squared minus 12n. Okay, so these ones were the most commonly missed on the quiz. The transformations, mostly because you're getting lazy and you're not writing the notation out. So let's practice that notation, and then using what we know about function notation, vertical shrink by a factor of 1/2. So this is number 25. That's 1/2 times f of x, which means you're going to multiply everything outside the function, that means everything that's not under the radical, by the shrink factor. So that means it's 1/2 square root of 3x minus 1 plus 1/2 times 6, 3. So multiply in front of the parenthesis, the radical, and to the number on the outside of the radical. The next is a horizontal translation, left 4. Let's do that in blue. Left 4 is f of x plus 4. So we get 1/2 square root of 3, and I have to substitute x plus 4 into my x, minus 1 plus 3. 1/2 3x plus 12 minus 1 plus 3. When we have these horizontal shrink and stretch factors, it means I can't just add and subtract the 4. It takes more when it's a shrink to make it move over that much. So my final answer, 3x plus 11 plus 3. This is the new function, g of x. A horizontal shrink by a factor of 1/3. That's f of 3x, followed by a reflection in the x-axis, which is negative f of x. So I'm going to take this square root of 3x minus 1 plus 6, and I'm going to put my horizontal stretch factor or shrink factor in there. Remember, the horizontal is reciprocal, so what goes in the equation is the reciprocal of what's in the words. So it's 3x. Square root of 9x minus 1 plus 6. And then I need to multiply the whole equation by the negative. Everything that's not under the radical gets multiplied by the negative. So that means it's negative radical 9x minus 1 minus 6. It has to distribute. So my final function, g of x, is negative 9 times the square root of, negative square root of 9x minus 1 minus 6. And number 27, a vertical stretch by a factor of 4. That's 4f of x, which means I'm going to multiply the entire equation by 4. So 4 multiplies in front, 4 square root of 3x minus 1, and the 4 multiplies to the plus 6, plus 24. Then a vertical translation down 7, that's f of x minus 7. So we have 4 square root of 3x minus 1 plus 24 minus 7. And that's 4 square root of 3x minus 1 plus 17. And that's your new function, g of x. All right, graph the function using a t-table. This is the one that we can't really use our transformations for. It gets too confusing. So you're going to take what's under the radical, and we're going to find where it needs to start. 1/2 x plus 1 has to be greater than or equal to 0. So I want to know the number that makes it equal to 0, and that will start my table. Subtract 1. 1/2 x equals negative 1 times by 2. So x equals negative 2. So my table is going to start with negative 2. And I'm going to count by 2 because it's 1/2. So I'm going to go 0, 2, 4, 6. And then we'll see where we go from there. My goal is to get perfect squares under the radical. So we're going to start by plugging in negative 2. Negative square root of 1/2 times negative 2 plus 1. That's my dog snoring in the background. And so that's negative the square root of negative 1 plus 1 is 0. Plus 4, so negative 2, 4. That's going to be that starting point. And this is a reflection, so it's going to go down from there. If I plug in 0, I get negative square root of 1/2 times 0 plus 1 plus 4. That's negative square root of 1 plus 4. Negative 1 plus 4 is 3. So 0, 3. Then I plug in 2. I get negative square root of 1/2 times 2 plus 1. That's 1 plus 1, square root of 2. I'm moving on. We don't know that one without a calculator. Negative square root of 1/2 times 4 plus 1. Well, that's 2 plus 1, square root of 3. I don't like that one either. I'm going to move on to, oh, I forgot to put my 3 here. So I'm going to skip, and let's try 6. 1/2 of 6 plus 1, that's 3 plus 1. Okay, I'll continue with this because I know the square root of 4. Plus 4, that's negative 2, plus 4 is 2. So it goes out to 6, 2. I skipped these because I don't know the square root of 2 and negative or square root of 3 without a calculator. Then I go out to 6 and 2. So my function looks like this. My domain is that x is greater than or equal to negative 2. And my range is y is less than or equal to the 4. Less than because my graph is going this way down. This one's greater than. So my x's are going greater than, but my y's are less than that.